Hello everyone, this is Mrs. Blenda here with a video that's going to talk about negative and zero exponent properties. Now I want to make sure when we're talking about these, we all know the right vocabulary to talk about. So here's my power here. I've got 3 to the 4th power. And when I'm talking about that as a whole unit, I'm going to talk about the power. 3 to with an exponent of 4. And when I'm talking about just the number that is being multiplied, that is the large number, I'm going to call it the base. And of course, we know that the small number in the upper right-hand corner is the exponent. And what this exponent is really doing is it's telling us how many times the base is going to be multiplying with itself. So this power, this 3 with an exponent of 4, means that my base will be multiplying 4 times because the exponent is 4. So that's how many times the base will be multiplying with itself. Remember about our exponents is that they only affect what they touch. So we'll keep this in mind as we go through and we talk about our exponent properties, that these exponents are only going to affect what they touch. Now, our first topic here are these negative exponents. So a negative exponent sort of indicates an inverse relationship. What it means is that I'm actually going to be using the multiplicative inverse, which means I'm going to take that power and flip it to the other side of the fraction. So what I see here for my example is I have 5 to the negative 3 power. And I could think of this as being, in a fraction where I've got a 1 on the bottom. So the negative 3 as the exponent means that I'm actually going to have the inverse. It's telling me this power is on the wrong side of the fraction. What I actually need to do is flip it down to the bottom. And once I do that, now it has a positive exponent. So it's like that little negative in the exponent actually means the power's in the wrong place. I need to move it to the other side of the fraction line. So whenever I see that negative exponent, that's what I'm going to think about doing. So let's talk about these examples down here. Now I see right here, I've got 10 to the negative 4 power. And again, that negative sign is telling me that this power is on the wrong side of the fraction. So since it's, not showing a fraction, I can always think of that as over 1. And that negative exponent means that what I really need to do is drop that 10 to the 4th power down to the bottom of the fraction. That's where it belongs, because now, once I've moved it, it's got a positive exponent. Okay, now let's take a look at my next one. Now this one looks a little bit more complicated because I've got some parentheses here, but this parenthesis just means that the negative 2 is the base. Okay, and I see here that what my exponent is touching is the parentheses. So everything inside the parentheses is being affected by that exponent, which means that negative 2 will drop down to the bottom of the fraction, and now it will have a positive exponent. And so if I were to expand that out to show that it is in fact multiplying 5 times, I would expand it out showing that I've got that negative 2 on the bottom multiplying all 5 times, because it is the negative 2 that is being affected by that exponent. So that's how I would have to keep track of that negative if I was writing it all the way out in expanded form and then figuring it out from there. Okay, but for this one, we're just going to be talking about how that negative exponent affects it, which means I'm just dropping it down to the bottom of the fraction line. Okay, now for this next one, see how it looks almost the same, but now I don't have parentheses. That means that this negative 5 is only touching the 2 and not the negative. That means that that negative is just sort of going to stay in place where it was. So I'm just going to set it out there because it is not being multiplied 5 times, just the 2 is. But that 2 does still need to drop to the bottom of the fraction. And I do need to keep that exponent with it, although now it is a positive 5. Okay, so the negative is still part of the problem, but it's not part of the power. So it's just going to hang out there on the front all by itself. Okay. Now, what happens if my negative exponent is on a power that's already on the bottom of the fraction? No problem. That negative exponent still means exactly the same thing. This power is on the wrong side of the fraction line. So that means I'm going to take this x to the 8th power, the negative 8 power, and when I move it up to the top, now my fraction line is down here, Now I've got that on the right side of the fraction line and it has a positive exponent. So if it starts on the bottom, we're going to do exactly the same thing. We're just going to move it to the other side of the fraction line. That negative exponent means it's on the wrong side. Okay, so I move that guy up to the top. Do I really need to write that it's over 1 power? Absolutely not. Okay. If you do, it's not wrong, but it's totally not necessary. Okay. Now for this next problem, I've got r to the negative 3 over 7. So again, this negative 3 power is indicating that this negative 3 exponent means this power is on the wrong side of the fraction line. But I see I also have something hanging out here below the fraction line. It is not touching the exponent, so it is not going to be affected by the exponent. It's going to stay exactly where it is, right there on the bottom of the fraction. It is the r that is going to move down. It is touched by the negative exponent, and so it will be moving to the bottom of the fraction line. And because everything moved down, I have to leave that little 1 up above. Remember, we can always think of this as being 1 times our power. So if we move the power down, that 1 is what's left behind. Okay. Now our next example, I've got a couple of letters over here, and I see that my exponent is on the power below the fraction line, and because it's negative, that power is on the wrong side. So that means that this h has to move up. What about the g to the 4? What happens to it? Nothing. It doesn't have a negative exponent, so it's going to stay exactly where it is, multiplying by itself 4 times. And the h is going to move up to join it on that side of the fraction line. So now they are both up there multiplying happily on the top of the fraction line. Okay. So that's our negative exponent property. It just means that our power is on the wrong side of the fraction line. So if we see that negative exponent, we just got to move it to the other side. Okay. Now, the other rule that I want to talk about today is the zero power property. And this one is really easy. Anything to the 0 power is 1. So if I have 392 to the 0 power, well, that's equal to 1. If I have x to the 0 power, well, that's equal to 1. So if I have 4 multiplying with x to the 0 power, that means what I really have is 4 times 1, because this x to the 0 power, that's 1. And so I actually just have 4, because 4 times 1 is 4. Now let's take a look at this last example. This is going to take everything that we've just talked about and kind of put it together. Now I see that I have r to the 0 power, so anything to the 0 power is 1. So instead of 2 times r to the 0, I'm going to write 2 times 1. And I see that I've got this negative exponent here. That means that that power, that m power, is on the wrong side of the fraction line. So I need to move it down to the bottom. So now I've got m squared, because once I move it, it's on the right side, and so it's positive on the bottom of this fraction line. Well, I know 2 times 1 is just 2. I don't have to write it out as 2 times 1. So I end up in my simplest form. I have 2 over m squared, and there is my happy simplified power right there. Okay, and that is the negative and 0 exponent properties.